Hello class. This presentation has 105 slides, so I'll go fairly quickly, but it's really key to what we're going to be doing later in the semester. So we're talking mass storage. Now, in the old days, this was called a second part of the hard drives, but mass storage is meaning a lot more different tools and different techniques. So we'll start off by looking at some of the older technologies. We'll look at partitions, formatting hard drives, the legacy partitions, and how to maintain and troubleshoot them. So partitioning. Here we're subdividing the physical hard drive into smaller portions. The smaller portions are easy to handle. Each hard drive has to have at least one partition. Traditionally, the hard drives are either labeled C or D. A and B were reserved for floppy drives. Once we format this, we install a file system onto a drive. The organization of each partition is so that it can store files and folders. What most people don't understand, when you format a hard drive, you're basically changing this, not wiping the information off of it. A lot of politicians were shocked. Now, partitioning methods. Okay, the older style, we would use a master boot record, and it was readable by other utilities. It was called the basic disk. Now the GUID partition table is a newer scheme and it replaces the MBR. It's called a basic disk. We'll see this later in our experiments. And Windows proprietary dynamic storage partition scheme is called a dynamic disk. The nice thing about a dynamic disk is you can use it to telescope up and down as needed. Now the first sector of an MBR hard drive contains the master boot record. It's a small amount of data that contains the partition table. It tells the computer where the partitions are, how big they are, how many they are. Now, in the old days, the MBR could support up to 4 partitions. So the instructions in the MBR use the partition table to determine which partitions contain the active operating system. You could only have one partition as active at a time. Here we go. Now, it's not coincidental that all of this is located on the outside of the platter. Good news, bad news. It moves faster. You can read it faster. However, it's usually where the damage will occur. So the master boot record looks for a partition. The partition tells the master boot record where to look. Okay. Then, after the MBR locates the appropriate partition, the partition boot sector loads the operating system onto the partition. Cool. There we go. Now, so we load the most basic stuff from the computer. We're doing the BIOS, then the operating system. And the MBR partition table supports primary partitions and extended partitions. Now, primary, designed to support bootable operating systems, can only be one active. Extended are not bootable, and a single MBR can have up to 4 primary partitions or 3 primary partitions and 1 extended. Here we go. Here's a picture of it. Now, even primary partitions on a single drive have a special setting stored in the partition table called active that determines the active partition. If you have more than one operating system installed on your computer, all right, it will only let you have one active at a time. Usually will ask you, well, while you're booting, which one do you want to boot to? To control this, then, the boot manager software yanks control the MBR, asks you which one you want to boot. Once you set that as active, then this gadget called the Grand Unified Bootloader, the GRUB, okay, will let you install it. There we go. Here's a picture, a bunch of these things installed. Now, with a 4 partition limit, an MBR disk is limited to 4 drive letters, and you can only extend the partition if you can overcome those limits. So an extended partition can contain multiple logical drives, each of which can get their own drive letter. A logical drive works like a primary partition except you can't boot from it. There we go. So we're extending it out a little bit. Again, we're coming up on something new. And that was in the introduction of the Windows 2000. We went from how we look at partitions, and we went from calling them volumes, or from partition to volume, and you could have span volumes over multiple drives. Now, this was a big one. Remember, we're doing a lot of things around 2000, and we started using networks like we'd never used them before. So, being able to span the volumes over multiple drives, we could actually increase the amount of space available. Since we can have multiple volumes, then we could give them different names, letters, etc. And it also had the implementation of RAID for the first time to home computers, etc. Now, if we look at this, Windows 7 didn't do it. Windows 8 and 10 would let us do this with dynamic disks, and Windows servers would let us go to RAID 5. Now, we'll see later that was key. That was one of the first big server RAIDs. Then we have this GUID partition table. Here, the globally unique identifier partition table follows some of the principles as the MBR, but it got over a lot of the limits. For instance, a GPT drive can have almost an unlimited number of primary partitions. When you go to a class, a lot of times they'll say, here's your iDrive, it's tied to your account, and they set that up ahead of time, and that's how they do it, simply partitioning. The MBR partitions have a limit of 2.2 terabytes, but the GPT has only limits in the zettabytes, so we're taking a look at exponentially larger. Now, the GPT is arranged by LBA instead of sectors. Okay? LBA 0 is the protector of the main boot record. And then hidden partitions. Okay, a primary partition that is hidden from the operating system is used for backup purposes, sometimes called the factory recovery partition. I was stunned when I got a backup disk from whoever I bought my notebook computer from. I thought, hey, I could install another operating system on another computer. It never could work, and I couldn't figure out why. Reason was basically it's hidden, and when you go to use it to repair, basically it'll let you reinstall. A swap partition is found in Linux and Unix, acts like RAM when you need more RAM than you have installed. And they use something called a page file. Now, this was popular back when RAM was extremely expensive and you couldn't get it. We could use part of our hard drive. It was slow, it was clunky, but that's what we did. Now, when to partition. You can partition when you're installing a new operating system or when you're adding a new hard drive. We'll get into the device manager big time. The older versions, you had to use something called fdisk. It was not pretty. Modern versions use the disk management tool. Linux has fdisk, and let's see, current versions can resize, but it's non-destructive. In the old days, if you changed something, everything went bye-bye. So here's fdisk, which is basically a console command, and then here is Windows 10 disk management tools, and this is in the device manager. So the naming problems. Okay, so the MBR and GPT disk use partitions and dynamic disk for volumes. Unfortunately, when you create a new partition, okay, looks like you're going to create new volumes. Yeah. So now I can start putting new names. Oh, here. Now we're at the disk management tool here, disk management or disk manager. You always want to go in as the administrator, which you should be on most of your machines. If you're at work, you probably will not be able to do this. Anyway, here's where the tools are for a simple volume, span, where you're going over multiple volumes, striped or mirrored. Now this is going to be big in RAID, as we'll see in a minute, but this is also your first indication that I can do this in the software. Two types of distinctions for RAID. It's either a software RAID or a hardware RAID. The software RAID's not quite as powerful, easy to set up, and all you need is a couple of hard drives You can do it in a matter of minutes. The RAID that's on the hardware has to be set up during installation. Here we go. Look at this. You take one drive and you can name it anything you want. Now, hard drive formatting. So, formatting configures a partition to hold files and folders suitable to the operating system. Two major functions. They create a file system, and it also creates a root directory. Do you see anywhere here where it deletes old files? They're still there. You're simply writing over them. This is why it's so dangerous to give somebody an old hard drive. Somebody who's smart can probably read it. There are companies that claim that they can read anything. Now, the file system, we come a long way just as we have with processors and technologies. The old system was FAT, which was basically FAT16 and not so big. Then FAT32, basically 32-bit systems, NTFS, 64, and then exFAT was for removable media, which was a little bit bigger. So a block is a base area of storage on a hard drive, and it could store up to, let's see, 4,000 bytes of data. The file allocation table was the way that we kept track of it. Now, we don't do this anymore manually. It's all done with software, but determining which sectors store various parts of a file is called data structure. Now, a 32-bit FAT used 8 hexadecimal digits. Now, that's pretty powerful. Instead of 2 to the power of 8, it's 16 to the power of 8. The FAT is a 2-column spreadsheet, and with that, you should be able to locate anything. And it has basically 2 types of statuses, good or bad sector. Full format creates the FAT and then writes and reads from the good sectors. Okay, make sure they're good. Now, Windows looks for the first cluster marked with zeros, good and available. Then, if the file fits in that cluster, it puts it in the status column. If the file is larger than the cluster, Windows finds the next open cluster. Okay, and then let's see, open the cluster, and process continues until the file's stored completely. And the last status, remember these different things, is the zeros and Fs that shows end of file. So you're putting them across clusters. There we go. Bad block, bad block. And here, 3 blocks store the mom.txt file. So when you see this FFF, end of file. Now, FAT32 offers 4-bit clusters, and you can have a partition of up to 2 gigabytes. All right, FAT32 primarily used for smaller flash drives, media, etc. It's not used for operating system partitions. There we go. So remember this. So drive size with these clusters starts out at 512 megabytes and maxes out at 32 gigabytes. Okay. Then fragmentation. Think of your closet. You guys have a front closet. You put stuff in it. Eventually, you have to take everything out and repack it to get it back in. So what happens is, as the individual files are broken into pieces, you find out that they're not stored in continuous clusters. So the fragmentation slows the system down, makes it harder to read and write, but things such as defrag arrange it optimally. Incidentally, don't want to do this before an operations review. Do it when you've got time and nobody has to use the computers. There we go. And here they're showing you defragmentation. Blah, blah, blah. Let's go on past that. Now, the NTFS, this is the system that we're using currently, was introduced at Windows NT. That was not Windows Northern Telecom. That was Windows New Technologies. And it's the file system of choice today and had major improvements. Redundancy. Ooh, can we say RAID? Security, compression, encryption, disk quotes, and cluster sizing. So all the modern tools that we come to apply on or rely on are there. Okay, so NTFS provides redundancy, uses an enhanced file allocation table called the master file table, And this keeps a backup copy in the middle of the disk. Remember where most of the damage occurs? On the outside. So if you have it on the middle of the disk, you can back it up and restore it. Security is provided for objects, provides file and folder access control, and then it also has this user access control list to grant or restrict access. Remember, starting 2000, we had to be much smarter in who we gave access to. Here we go. Here's the defragmenter working. Compression. Let's see, they could actually compress them slightly. It's not as big as you'd think to save space. You can do it with Windows or Files Explorer. And the encrypting file system encrypts the files, and they're unreadable to anybody without a key. Files and folders can be encrypted or compressed. Do not lose the key. Disk quotas tell you how this users can use the space on a per drive basis. Cluster sizes also can be adjusted, but generally it's rare. NTFS supports up to 16 terabytes on a dynamic disk, but it's limited to 2 terabytes on a basic disk. Here's that term again, dynamic and basic. There we go. Here's where we can set our controls. Now with NTFS, ooh, look at this. So we're going from a much smaller size to immediately to megabytes to terabytes, okay? And cluster size can be up to 128K. Now exFAT, the USB drives are considerably larger, and how large can they be? I've seen them up to the terabyte range. So the FAT32 doesn't work with them too good, particularly when they're beyond 2 terabytes. So this exFAT replaces the FAT32. Supports files up to 16 exabytes. Mama! You think we'll never get there? We will. Theoretically, you can partition up to 64 zettabytes. This extends the FAT32 from 32-bit clusters to 64-bit. Remember, when you go from one technology to the other, it doesn't go up as a multiplier, it goes up exponentially. It does not have NTFS tools such as compression and encryption. Now, Macs, similar to PCs, and they have a hierarchy. Okay, you can read and write to several file systems with the OS. The latest version can read and write to FAT32 and exFAT, but can only read NTFS. All new Macs, okay, come with the Apple file system. Now, I don't have a Mac, so we're just going to have to look at that. Now, file systems in Linux. Okay, they're using what's called the fourth extended file system. Let's see, supports volumes up to 1 exabyte and with file size up to 16 terabyte. It's backwards compatible with earlier ones. Linux files, let's see, system compatibilities are bigger than Mac OS. Now, point that out because the Mac and the Linux are similar in their root. Now, bootable media. Any removable media that has an operating system installed can be used for starting the computer. Optical disks or a flash drive. All Windows and Linux installation CDs and media has an image of an installation disk. When we work with the Raspberry Pis, we'll get a look at this. Now the installation screen is pretty simple. Most of you have seen them before, but they'll basically ask you some basic information. You'll make some choices. For instance, here's where you can format and partition the hard drive, so to speak. Okay. Disk management for Windows 10 allows you to go a little bit further. And then you can have either reserved partitions with unallocated space or allocated space. And then the disk management, primary tool for partitioning and formatting drives after installation. Now this is key with local area networks because you'll have to be doing a lot of work in terms of who does what, who gets what. To make it secure, you're going to have to break it down into areas where people can and can't access. Okay. So in a Windows system, this process places special information on a hard drive. It identifies the hard drive, what the hard drive does. All drives must be initialized before you can use them. And let's see, To initialize the disk, right-click on the icon, select Initialize, and you get the option for MBR GPT start type partition. Now, you can view the status of a drive in disk management. It will tell you if it's healthy, unallocated, active. If it's a foreign drive, it means it's unknown dynamic disk. It'll let you do formatting. It'll tell you if the disk is bad, whether it's working, or if it's been corrupted. So you have a ton of control over this. Now, to create partitions or volume, right-click on the unallocated part of the drive and select New Simple Volume. You can specify the volume size and click Next and assign a drive letter. So first three volumes are called primary partitions. There we go. Again, we'll have a lab on this. So you can use your partitions and set them to be anywhere from 4 to 32 gigabytes, and you can use FAT32 or NTFS. If it's larger than 32 gigabytes, you can only use the NTFS. Okay, full format test the disk clusters. The quick format does not. Go. Then create a dynamic disk from a basic disk. Basically, it's a simple volume, which acts just like a primary partition. A span volume extends the partition of a single unit into unallocated space or extends the volume to grab extra space on completely different dynamic disks. So we're able to combine disks. There we go. We're converting to a dynamic disk. Here's our wizard. And then take a look here. We've taken a drive, we've split it up. We can also combine them. We can use stripe, span, etc. And we'll be doing that with our RAID experiment. Now here's the cool thing, all right? Extended volume. So you've got another disk, you put it there. Good. And then it appears as one disk. Up here, you'll see the multiple disks down here. Okay, additional types of volumes. Striped volume. 2 or more dynamic disks that spread out blocks from each file across multiple disks. Now that's good because, you got 2 SATA cables. They're doing read-write, okay? And it's also a way to reduce the risk of something bad happening and damaging the computer. A mirrored volume, this is with Windows 7 and later. It actually sets 2 drives for data redundance. One is the mirror of the other. If one drive fails, put in a new drive and you will be able to rebuild that mirror image. There we go, showing stripes, mirror. Yeah, it's pretty simple. Read over that. Then other levels of RAID. RAID 5 arrays uses 3 or more disks, and it has a robust solution for storage. Okay. RAID 0 plus 1, or RAID 10, if you will. You have to have third-party software implemented as part of a hardware RAID. Now, mounting partitions as folders. Partitions and volumes can be mounted as a folder on another drive, or the mount point. Enables existing folders to store more data that can fit on a single drive, partition, or volume. You have some nice gadgets here. Look over that. Then assigning and changing drive letters and paths. Right-click on a drive and you can change the drive letter and the path. You can format any Windows partition in the Windows Explorer or File Explorer. Now, the disk management is the preferred formatting tool. That's where the big boys go. Now, storage spaces. Okay. You can group 1 or more physical drives of any size into a single storage pool. It's available with Windows 8. Functions like a RAID management tool, such as simple, mirrored, and parity spaces. Thin provisioning allows the creation of a space with more capacity than the physical drives will allow. Go. Maintenance. Okay. Things that can go bad. You can have a hard drive fail. The clusters get old. The magnets don't work. The magnetic domains get old. And that's with the traditional. So what you can do is you can do check disk, etc., and you keep the information organized to get rid of the bad clusters. You can check for errors that way, check for invalid file names. You can do this with scan disk, disk utility, or command line tools with Linux. There we go. More check tools. Play with those in lab. And then defragmentation. Okay, they're saying it's a good monthly maintenance thing. Incidentally, maintenance is important. Most people don't realize that good maintenance means that things will work properly for a longer period of time. And it's like being an anesthesiologist, network administrators. You know, it's boredom followed by stark terror when things go bad. Everybody's on your case. There we go. Now, disk cleanup. Okay, you're getting rid of files that you don't need, temporary files, downloaded programs, etc. And you can access this disk cleanup in Windows 7, 8, and 10. And more on that later. Then troubleshooting. 4 broad categories for hard drive failures: installation, data corruption, dying hard drives, and RAID issues. So if you do a good job, follow good procedures, installation should go well. Okay. So let's see, CMOS cover really partitions. If you don't partition them properly, wrong sizes, they don't work. Then failing to format a drive makes it unable to hold data. And what good is a drive if it can't hold data? Go through the mental installation to identify errors that may have occurred during installation. You'll be doing a lot of them. It's important to take your time, make sure it's quiet, and do it right the first time. It's much easier than trying to recover it. Now, data corruption. It can be due to power surges. That can happen due to external forces. When you put in a new device, construction, lightning, hell, I don't know, anything like that. Typical error messages tell you that something's not right. Okay. Yeah, try running your error checker. This is where the RAID comes in so bad. If something is bad on one, having it striped elsewhere, you'll be able to check. Okay. There we go. Then a dying hard drive. Okay, if it's clicking, making sound, if it smells funny, grinding, bumping, back it up. Back it up now, not later. Now. It's going to go on you. Can you repair a drive? Not really. So if a drive with an operating system dies or locks up or no boot present, you may have to go in and see if you can find that partition and get the operating system reinstalled. If a second drives, it'll show up in Windows Explorer. Drive problems in RAID are almost always identical to individual drives, and there are a couple of unique RAID errors, however. If a drive is not recognized, okay, make sure they're powered and they have the proper connections. On a motherboard, only RAID may require you to use certain special RAID connectors. For instance, sometimes I'll see a bank of 8 SATA connectors. Only 6 of them can be used for RAID. Then, symbols when RAID stop works include, let's see, blue screen of death. Usually you get a notification of a drive failure. You usually, look at this, won't lose data, but you must replace the failed drive. This is a showstopper and a career builder. If you did not take the time to install RAID where you have fault tolerance, then it can be a disaster depending upon the data. Now, RAID, not found errors. So, it varies greatly depending upon the type of RAID you use. However, let's see. It'll always show up in the configuration utility. If an existing RAID stops working, you enter the configuration utility and find the RAID is gone. You either have dead drives or faulty controllers. It's a big problem there. Okay, storagereview.com. Okay, good one. Haven't played with that much. However, you can get